Imagine watching a grandmaster solve a complex Sudoku puzzle perfectly. Are they meticulously calculating every step using logic, or are they just making wild guesses until the pattern clicks? This paper investigates hierarchical reasoning models to determine if they are truly reasoning or simply lucky guesses. Standard large language models often struggle with heavy logic puzzles like extreme Sudoku, frequently achieving 0% success. Hierarchical reasoning models, or HRMs, solve this by thinking in latent space, updating internal vectors repeatedly to find a solution without generating a single word of text. However, upon closer inspection, the researchers found 3 critical flaws suggesting these models aren't actually using step-by-step logic. The models often fail on trivial puzzles, drift away from correct answers if left running too long, and get stuck in false attractors or local minima within their internal state. This behavior violates the core fixed-point assumption, which states that once a model finds the answer, it should stay there. In reality, the researchers discovered that because the models were never trained on intermediate states, they behave chaotically, often drifting from a correct answer back to a wrong one. With the diagnosis that the model is essentially guessing and getting trapped in unstable states, how do we fix it to improve reliability? This figure visualizes the model's thought process projected onto a 2D plane. You can see particularly in panel B how the model actually starts with the correct answer, but then inexplicably wanders off into incorrect territory, proving it hasn't learned to recognize when it has succeeded. To fix this, the authors treated the reasoning process as a search for stability. By forcing the model to practice on easier puzzles and running multiple distinct guesses via input perturbations, they skyrocketed accuracy on extreme Sudoku purely by managing the randomness of the search. Recognizing that AI reasoning might look a lot like parallel guessing is a crucial step toward building robust models. For more insights on mechanistic analysis, visit emergentmind.com.